Hey math fans, this is getting started on our practicum for indirect measurement. We're going to measure how tall things are. Now I'm going to give you some directions later on how tall what, but for the moment I'm going to talk about this tree. Okay, things I'm going to need to be able to measure this tree, to get around to it. Okay, I need something, like a ruler. Okay, here I've got a yardstick, except it's not really a yardstick because it's like 4 feet. It's from Bearings. They used to have these ones that were wonderful. They don't have them anymore. I wish they did. They're thick and nice and they really work, and I've had it forever and I can't get another one. I wish I could. Okay, so you could have something like yardstick. You could have, this is a really fun type of measuring thing. I think a lot of carpenters may use this. See, it's a fold-up ruler. Isn't that cool? And you can use it for different lengths, and it's handy because you can have it be different lengths that will be convenient to you. And it's about 1/2 foot for each one. Those things work if you happen to have one of those. You could have a tape measure. A tape measure will work great, except if you're going to use this tape measure, you ought to be careful about it. And why you ought to be careful about it is, well, I use this one to sew, and you notice at this end there's a 1 and there's a 60, but there should be a 1 and a 60, front and back on the other end too. But somehow it only goes to 50 and it starts at 10. And so I'm guessing that at some point either it magically disappeared, Scotty beamed it up, or else I cut it while I was cutting some fabric and I didn't realize that I'd done it. So that probably happened. And so if you've got a defective tape measure like I've got, then you have to adjust for that, like measure from the other end. Another thing, this is my handy dandy tape measure from my father. This was my father's. See, it's a very old Craftsman. It works really good and it pulls out, and you can like stop it right there, push the thing in to make it. This works really good. This goes for 20 feet. For some of the things that you're going to do, you're probably going to need at least 10 feet, if not close to 20. Of course, you can also use just a plain old ruler, because you're going to have to use it a whole bunch of times, because if it's like 20 feet, you're going to have to do it 20 times. Another way that you could do measuring is that you could take a string. Here's some jute string, and just put the string at however long it is, like if it's a long thing. And then it might be easier, you could take, if all you have is a ruler, you could, like say it's this long, I can say, well, wrap it around the ruler, say there's 1, 2, 3, 4. Okay, so what I just did right there was 4 feet long a string. And so if you put your string the distance that you want, then you can measure how long it is, and that'll work too. I encourage y'all to have a little bit of ingenuity on doing this kind of stuff. There isn't just one way to do it. Okay, other things that you're going to need. You're going to need a clinometer. There's a separate video telling you how to make the clinometer, and also we did it in class, so it's from then. You're going to need a mirror. Probably works better if it's a small mirror. Okay, yeah, okay, so yeah, and some tape. Gonna need some tape. I happen to have blue painter's tape. Doesn't really matter what kind of tape, but it is going to be one that you're going to want to take off and not just leave there. Okay, so that's the stuff that you need. You also need your packet for how to do it. We'll talk more about that in just a minute. Okay, I'm going to talk right now about how to use the mirror. We're using the mirror to form similar right triangles, and then we're going to use it to solve our height of this tree right here by using similar right triangles. We'll say, well, how are you using a mirror? Put it on the, okay, what I'm going to do is I'm going to put the mirror on the ground. Okay? Okay, there's my mirror on the ground, on the pavement here, and I'm going to come back and show you. There's the beginning of the tree, then I'm going to find the top of it. Notice I can still, oh, look down at the mirror. You can see the tree in the mirror. Do you see that? Okay, you're starting to be able to see the tree in the mirror. Oh, wait. I look at the tree here. Where is it? And up is up. But I looked at the tree here in the mirror, and guess what? It's upside down. Look at it. There's the the trunk, and then there's the leaves that are starting to grow out. I just planted these last year. Isn't it cool? They're blooming, and maybe I'll get pears. They're pear trees. Won't that be fun? Okay, well, they're blooming. There's actual blossoms on them. But what I'm telling you right now is look and notice that as I step back in the mirror, I see the trunk of the tree. Okay? As I come closer to it, it's up. I noticed that it's upside down, and now I can start to see the leaves and the top of the tree. Now, just in case you're wondering, the tree is, where'd it go? The tree is not upside down. The tree is normal right side up, not upside down. So I look up at the tree, it looks like that. I look down in the mirror, the tree looks upside down. Okay, so I'm gonna try that again. So now I'm gonna get close. I want to see the top of the tree because I want to know how tall the top of the tree is. So I'm going to move myself and keep looking in the mirror, and move myself and keep looking in the mirror until I get to the right distance that I can see the top of the tree. Okay, I'm close. Okay, I want to get to the right. Whoops, now I can't see it at all. Okay, there we go. Okay. Yeah, I want the top of the tree. There we go. Okay. So now, and I'm going to get what I'm looking for. And in my case, I'm looking for the top of the tree. So I want to arrange myself so that I'm oriented so that I can see the top of the tree right in the middle of my mirror. Okay, so I have that now. The top of the tree is right in the, well, close. Let me see, let me back up. There we go. The top of the tree is right in the center of the mirror. That's what I want. So I'm going to stand right here and wait for my partner to measure for me. Okay? And I'll tell you in a minute what I'm going to measure. Okay? Okay, here we are trying to figure out how tall the top of the tree is by indirect measurement using a mirror. So here is the person that's trying to look and see the tree in the mirror. Your documentation calls this the observer, the one who's standing there observing. There's also the surveyor. The surveyor is the one who's going to be moving stuff around. The observer pretty much just kind of stays there. Okay? So here's the mirror, here's the observer, and the surveyor is off someplace else. So either the observer moves to get to the right place so you can see the top of the tree in the mirror, or the surveyor moves the mirror to the correct place, depending upon your circumstances. There might not be a lot of room for the observer to move, and so it's probably easier for the surveyor to move the mirror. I just didn't have a helper when I was doing it. I was the observer, and I didn't have a surveyor to move the mirror for me. It's probably easier for the surveyor to move the mirror and the observer to stand still. Observer, remember that when you look in the mirror at the object, it looks upside down. You're to put the top of the object that you're measuring in the middle of the mirror. Okay, and then you're to just stand there. Okay, then the surveyor is going to come and measure while you're just standing there. Going to measure a couple of things. Now they're going to measure, and this isn't very far, you'll be measuring the real thing, obviously, to the middle of the mirror. So observer, you'll tell the surveyor where on the mirror the top of the object is. Remember to be upside down. Don't forget, it's upside down. Okay, so the surveyor comes and puts out the measurement device. The observer tells them where the top of the object is in the mirror, and the surveyor measures from the top of the object in the mirror, which is upside down. Did I say it's upside down? Okay. To the base of the object. Now on this, I'll talk more when we're out on the site about where it needs to be relative to the object, and we'll do that a little bit more specifically later. So the surveyor is going to measure from the bottom of the object to the top in the mirror, and from the top in the mirror, so this one would be like 5.1 centimeters, And then from the top of the object in the mirror, which is, oh wait, upside down. Yes, I remember. From the top of the object in the mirror to the middle of the person that's the observer. So I'm going to say 2.4 centimeters. Okay, I'll talk more about the next measurement when I've got a live human to illustrate it on. But let me mention now that the height of the person is going to be the height of observation, not the top of the head. Do you see the light? Does the light come to your body through the top of your head? No, it does not. Where does it come? It comes in the eyes. So in this particular person, the eyes are at about 4.2 centimeters. So that would be the measurement I'm looking at. I'm going to be making triangles here, and it needs to be on the portion that we're actually seeing. So when we do it later and label it, now you're not going to draw on the people, but it'll be something like this. There'll be a triangle from where the light comes in, which is the eye, to the middle of, to the top of the tree, which is in the middle of the mirror. So that makes a triangle, and unless you're sick or falling down, we're going to assume, oh, this needs to be to the ground, I'm sorry. It needs to be to the ground. We'll assume that you're standing up straight, and we'll assume that this one is a right angle, okay? So that gives us the triangle, okay, down to the floor, because you're going to measure down to over here, in this case, dirt. So there's one triangle. Again, we're following the path of the light. And so for the tree, we're looking for the very top of the tree. So this will be straight down from the very top of the tree. Again, it's important that these bottoms be the same. Make sure the bottoms are the same on the same flat surface. This will be a right angle, we hope. I'll talk more about how to make sure that's a right angle in another session. And then here. So what do we have? We have the path of the light. Okay, the light that you see as the top of the tree comes here to show you the top of the tree, comes down, reflects in the mirror, and then comes up to the eye. So that's the path of the light. Okay? This is the path of light. Okay? For some of your exercises, you want to know how far the light travels. That's from the top of the object you're measuring. You're saying, but that's not a light source. The tree's not putting out light. I know the tree's not putting out light. Outside, the sun's putting out the light. But the light comes with the image of the top of the tree, and that light reflects in the mirror and comes to my eye. That's the light I'm talking about. Not that the tree generates light. I know the tree doesn't produce light. At least these trees don't produce light. They're pear trees. They produce pears. I hope. I've never had pears from them yet. Won't that be neat? Okay. So one time you're going to want to know the path of the light, and one time you're going to want to know the height of the tree. So when you want to know the height of the object, in my case a tree, so the height of it, up, and then the height of the observer. Remember, the height of the observer is the height of the eyes where the light comes in. It's not the height of the whole body. Oops, two yeses. Okay, that's the height you're looking for. It's for the height of the eyes. So whoever's working with you, being your partner, you're going to need to make sure to get up to their eye, going straight down best you can without poking them in the eye. Poking them in the eye is not a good idea, so avoid doing that. As we get into how we're going to work on this project, let's look and make sure that we have a few little bit of terminology going with us. When light comes in and reflects, it creates two angles. The first one here, the angle of the light, the pathway of the light with the mirror surface, that's called the angle of incident, the angle that the light hits it. This angle here, is the angle of incidence. Then the mirror reflects, and the angle that the path of the light makes with the mirror is the angle of reflection. Guess what? The angle of incidence is always equal to the angle of reflection. Now, you already knew that because you can try looking around the corner and try to look at your kid brother, kid sister, just look at them just right and see what they're doing. Yeah, you learned it instinctively how to work with it. The angle of incidence is equivalent to the angle of reflection. Okay, in your packet of materials, let's look at how you're going to be working through this. This is the first way to do it. It's by similar triangles. So you're going to do it 3 different genres and 2 different ways for each one. So you'll be measuring the height of your thingamajig 6 times. Here's the first way, although you can do them anywhere. The first way is by using similar triangles. Here we'll have 2 triangles, and we'll figure out that they're similar. Go ahead and write in the name of the observer and the surveyor. Notice you need to mark everything. Do it. Where's the angle of incidence? Write it in. Where's the angle of reflection? Write in. Angle of reflection. Put hash marks, arc marks to show which ones are the corresponding angles. And you're going to need to draw what you're doing. Okay, well, your thingamajig, when I was standing out on the pavement, my thingamajig was a tree. So if I have a tree here, and I'm looking at the top of my tree, this is my thingamajig. And you can go ahead and label what it is so that you'll remember what you're dealing with. Here's my tree, my beautiful pear tree budding out. Isn't that great? Okay, I hope I get some pears. So there's my thingamajig. And what have we measured? Let's say, for example, when it was measured, what we found is that on the ground, from the person at the location directly below their eye, to the mirror, was 12.2 centimeters. Go ahead and label that. And from the mirror to the base of the thingamajig, directly under where we're measuring the top, it's 30.3 centimeters. The height of the person, the observer, to the eye is 162.5. Okay. And now, just a reminder, for this project, as long as you have some of your measurements that are bigger than about 5 feet or so, it's fine to use either centimeters or inches. That's fine. I personally would use inches because most of my devices, my measuring things, have inches and not centimeters. But when you do, convert it all to inches. Don't try to use feet and inches. Okay, so there's, we've got it. We've got it labeled, and we see that we need to find out the height of the tree. We're going to set up a proportion. When you set up a proportion, I want you to do a 2x2 chart every time. Okay. Not because it's hard, but because it's easy. Easy, easy, easy peasy. Too easy, you'll make mistakes. So rehearse with yourself. Okay, this wasn't a window. This was a tree. That was my thingamajig. And so as I go along, I'll mark what I'm actually doing to help me keep track of it. And you do that too, because I mean, otherwise you're gonna get a little confused maybe, and it needs to say what you're actually doing. So when I look at it, I'm gonna say in my head, the person and the height, the person and the height, the person and the height, 162.5. Okay, the person, distance to mirror, person, distance to mirror. Person, distance to mirror, 12.2. Then the tree, the height of the tree. Oh, that's my thingamajig, and that's what I'm trying to find out, so that must be my variable, so I'll call it x. And the distance between the tree, my thingamajig, and the mirror was 30.3 centimeters. Here, inside my 2x2 chart is my proportion. So you can go ahead and draw it as such and then solve it. When we solve this, we find out that the height of the window to the nearest millimeter, except, I'll say something, is 403.6. That's about 13 feet, and that's about right. You always need to have that reality check. does it seem like it's way too much or way too little, you might not have done it right. So always do a reality check. And again, if you have distances that are a little bit bigger, like many of you are going to have, you don't need to do the decimal point. Plain centimeters is fine, or plain inches is fine. Okay. Next thing you're going to do. Okay, you notice here there's the two triangles, and our two triangles here, I've got the tree triangle here, and the person triangle here. So these are our two similar triangles, which you will have marked. This down here is just copying these two so that you can tell what you're doing, hopefully. Hopefully it's not worse than better. So this is just a copy of the tree triangle, the thingamajig triangle. And this bottom one is just a copy of the person triangle. So those are the same. We're just working it down here to be able to have space to work it in. So go ahead and copy your measurements. I have 30.3, and oh look, I just found out the height, so it's 403.6. I can put it right there. Then for the person, it's 162.5 and 12.2. Okay, so at this point now, you've just copied the tree triangle down here, the person triangle down here, so that you'll have a little space to do your calculations and show your work. All right, we want to know the distance that the light traveled. Let's back up here and see where the light goes. The light that you're going to see as an image, the top of the tree, the light comes from the top of the tree down to the mirror and reflects into the observer's eyes. So this yellow path is what we're looking for. This is the path of light. Okay? That's what we're looking for. Okay? You look down here and see where the corresponding parts are to find your path of light, and figure it out and add it up and put it here. This information is going to go into your summary and conclusions. You're just going to copy the data from this page. It'll go here. Okay. For your data collection, put the people's names and put what you saw. This was a similar triangles method, and we just did the first trial. You'll do the second trial, and it'll be the same. Notice it's all the same. You just switch people, switch who's doing what, so that you each do each job, and make it a different distance. And if you can move around a different way and still see your same thingamajig, then that's good too. Okay, just make sure you measure through everything out again. When you're done, you'll go and put that one also in the second trial and write in what the things are. Okay. Hey there, math fans. This is on how to do the trigonometry part of the practicum. Being all safe here, but there's nobody around, and we're outside. So for the moment, here we go. My able assistants. This is Mr. Hamilton, Latin teacher at Bel Air High School, and this is Miss Holmes, who teaches, and I forgot which school you're at.
Shern Elementary.
At Shern Elementary. Cool. Okay, and they're going to help. The first thing we're going to do is figure out how to set up to be able to do our trigonometry. We're going to need good straight lines that are parallel and perpendicular, and they're going to help us with some parallel and perpendicular. Is that cool or what? It is. Okay. So now our able assistants, Mr. Hamilton and Ms. Holmes, are going to come and show us how to find some good parallels and perpendiculars. We've chosen this location because there's a balcony. Part of the requirement is that you need to be able to have a place that has a balcony that you can look at. Okay, so the first thing we're going to do is know what is parallel to the wall and perpendicular to the ground all the way down. So Mr. Hamilton has a string with a weight on it, okay? A string with a weight on it. The weight he's got is, it's the roll of string, and he's just got it taped so it'll work, okay? And so what he's doing is dropping it down, and then you can see Miss Holmes.
Reattach it.
Oh, it fell off, so we're gonna fix that. There we go.
You can tape it so that...
Okay, so what she's doing now is she's attaching the string to the weight, and the weight happens to be the roll. And this is called a plumb line. Plumb means right or straight, and so they're making a plumb line. So Mr. Hamilton is holding it down, and it will go parallel with the flow of gravity locally, and that means it'll be straight down. Okay, so now they're getting it ready, and Miss Holmes is going to make sure that it's not swinging, and Mr. Hamilton's going to make sure that it's nice and steady, and she's going to see where it touches the ground. When she does that, she's going to put some tape on the ground to know where is directly below. Okay, so that's what she's about to be doing now. Ooh, it looks like there's a piece of metal there for this one that's pretty close. Okay, Miss Holmes, is it right on the piece of metal?
It's not right on the piece of metal, it's about an inch away.
Okay, so go ahead and put it right where it belongs.
Okay.
And so she's taping so she knows where it is to be able to measure from. And notice the string going down, you can see it. It's right below the edge of the balcony where Mr. Hamilton is. Okay? We're going to be able to use this when we're doing our trigonometry to know where our good parallels and perpendiculars are. Okay? Okay, cool. So now what we have is we know directly what is directly below where Mr. Hamilton is. Now he's going to show us how to use the clinometer. Okay? The end of it that's near his eye. Tell me, Mr. Hamilton, where are you putting it? Over, how do you know where to put it?
Well, I need to put it right over the spot we just marked.
Yes.
So would that be out here?
No, you're gonna fall off. Don't do that. No.
Would it be like here?
Oh, no. Silly. Yeah, okay. You want it to be right in line with the string. So which end of the clinometer is over where the string is? So that's the one closest to you, okay? Yeah. So he's putting the clinometer directly over where the string is, and then that'll give him a good measurement. Okay, I'm going to back. The indirect measurement practicum continues. Here on the paper, your packet, is a setup of how we do it at the school. Well, y'all are not doing it at school. You're doing it on your own. You're choosing your own location, your own, if you've read it, thingamajig. Make sure that you read the attachment at the hub that gives the directions for doing things not at the school. It says like indirect, not at school. Make sure you read it to know how to do it. So we're not doing this. We're doing your own, and you're going to tell me about how you chose it and everything. Already talked about the similar triangles method. Now we're going to talk about doing the trigonometry method. Okay, everybody should have made a clinometer. Okay. Now this is not anything fancy. This is just your cheapy protractor from the dollar store and whatever you have around the house. A clinometer that you'd probably buy as one would be marked a little differently. Notice that when it's horizontal, which is the line of sight, the usual line of sight, that the string marks it as 90 degrees. Well, 90 degrees is not what we want. We want to consider this 0 because the string is at 0. It's flat. It's parallel to the ground. I said string. The straw is at 0. It's parallel to the ground. And so we want to know the difference between the line of sight and the line that the unusual line of sight, and then the line of sight that forms the angle of depression or the angle of inclination. That's what we're going to want to look at. So to do that, you need to understand that this really means 0. So what you're going to have to do is a little calculation here every time. It's not hard. You need to accommodate the difference between the normal line of sight and the way our measuring device works. So to do that, you need to take whatever you get, like if you measure this and you get that it is 110 degrees, say it's looking down like this and it's 110 degrees, then you'd take 110 minus 90 and take the absolute value. So you would write this down as a 20-degree angle, and that is an angle of depression. And it can come up here too. Inclination, raising your head up. So that's now at 70. Your eyes here. You're looking up at the top of your thingamajig over here, top of the thingamajig. Eye here. It's an angle of elevation, and it's at 70. So you do the same thing. 70 minus 90 is negative 20. So this is a 20-degree angle of elevation. So that's how you're going to get your angle of elevation and your angle of depression each time. Okay, just remember that with our devices, a cheapie from the dollar store, putting it together and making it ourselves, and being resourceful and doing what we can do on our own. Yes. Okay, subtract 90 and take the absolute value. All right, trigonometric method, we're going to do it from 2 vantage points. Okay, well, if you saw the video about with Mr. Hamilton and Miss Holmes, it's not at Main Street, it's at on the sidewalk. Okay, so we're starting from the sidewalk. This will be the sidewalk down here. And then this is going to be the artifact that we call a thingamajig. Okay, so here's my thingamajig. Maybe it's a modern art statue. That's my thingamajig. Jig. Okay, that's my thingamajig, but you can put the actual name of what you have. Like if it's a tree, or if it's a statue, or whatever it is. So what are you going to do? You'll stand here with your clinometer, and look at it. And again, don't forget, for all of these measurements, it's the same thingamajig at the same general location, but you'll be doing different things with it. Each time you'll do it twice, you and your partner, and you'll do 3 different things. One is doing it by similar triangles. One is this, doing it by trigonometry from the ground or whatever's at the bottom from wherever you are. And then the other one is from a perch. Okay, so what are you going to do here? Here is the observer, and the observer's got the little clinometer with the thing hanging down. Okay, and then the observer is going to find the 0, which is really marked as 90 degrees, but we know that it's 0, and look up. So that the line of this is the normal line of sight. You're to draw all this and measure and label it. So this is the usual line of sight. Okay, and then this will be the angle of elevation. Because remember, it's always relative to the eyeball of the person doing the observing. So this is the observer. So this is going to be the angle of elevation, and it will be measured. And of course, the surveyor will want to help and record with the observer as to how big of an angle that is. And then we'll have the angle of depression down to the bottom of the thingamajig. So make sure you label all this stuff, write in the names of who's doing what, just like the other time. and then you're going to do your trig here. Show your work. You have never heard a math teacher tell you to show your work, right? Yeah, you got to do that. Okay, so you're going to have some opposites, you're going to have some adjacents, you're going to have some hypotenuses. But hypotenuse, miss, we'd have to have a right angle. Oh, look, that's a right angle right there. So you're good, right? You're going to have some opposites, you're going to have some adjacents, and you're going to need to figure out the two portions of the height of the thingamajig and put those together to find out what it is. You're also doing, so the height of the window, oh, it's not a window, it's a thingamajig, from the floor. That's going to be this height. That's the combined. And then the distance that the light traveled from the window to the eye. Okay, well, is not a window, but from the top of the tree to the eye is going to be that distance right there. So this one's a little bit easier to calculate than it was on the similar triangles. So you'll do this, and then your partner, you'll switch roles, switch jobs, and change the distance from the wall. Okay, it's not a wall, it's wherever the thingamajig is, okay? One of you is going to be closer to it, and one of you is going to be farther, and it doesn't matter. Just make it not 3 inches or even a foot. Make it a fair amount. Now you're going to have to figure that out based on where you are and what kind of room you have, space to be able to deal with it. And like, you know, don't walk over a cliff or something when you're trying to be further away. Be reasonable about it. Be safe. So each of the two trials, one will be closer and one will be farther. Okay? So that's trigonometry from the base of it. Okay, doing trigonometry from the balcony. Well, what you might have might be a balcony. I've called it in general a perch. Any place that's safe that you can move around and do these calculations, you need to be able to see up to the top of your thingamajig and down to the bottom of your thingamajig. You'll do your normal line of sight. Make sure you draw this in and label everything with amounts and units and all that kind of stuff. So you'll have your normal line of sight. Use your clinometer. Yes, yes. Use your clinometer and measure the angle of elevation and the angle of depression. Elevation to the top of the thingamajig and depression to the bottom of the thingamajig. So your perch should ideally be in a location that you can look up to the top and down to the bottom. Now, it'll work some other ways, but let's make sure if you can do it this way, do it this way. Okay, work through it. So you're going to do it twice. These do not have to be from the same perch. If your site that you choose has 2 different places that people can stand to look up to the top and down to the bottom, hey, that's fine. It does not have to be the same. And matter of fact, it could be fun that it would be a different distance. So for you and for your partner, remember to write in who's the observer and who is the surveyor. Now, one thing that I forgot to tell you to do on the video with Mr. Hamilton and Ms. Holmes, you need to make sure that you do, and that is you need to know this distance here from the observer's eye to the ground that's even with the bottom of the thingamajig. You need to know that distance. So how would you have done that on the balcony that Mr. Hamilton was on and then down to Ms. Holmes? How would you do that? The string went from here to the ground. You can pull this, after you pull the string off, you can measure how long it is by wrapping it around a ruler or by using a tape measure or all that kind of stuff. Okay, so you need to be able to measure straight down and then also include the amount to go up to the observer's eye. It might be possible in your circumstances to do that all in one motion with one string and measure it, and that's just fine. Or you might need to do it in 2 portions. But make sure you get, this is going to be the height of the observer's eye. Same deal here. If they're a different perch, that would be a lot of fun. Then you're going to find the same, show your work, Show your work. Yes, my math teacher, I am. You're going to find the height from the top of the object to the bottom and the distance that the light travels. Again, the distance of the light travels will be this right here. Now, recording all of our data. Each one of these, you're going to take the data that you got from here. So these numbers down here, these numbers down here, and come and put them in this chart. Now, in this chart, it's already got in the height of the balcony at the school. So blow that off because you're not at the school. Okay? So put in whatever you have here. And again, this says down here all distances in centimeters expressed in an inch millimeter. Unless you are close to your thingamajig, you don't have to don't do the decimal point because over long distances, those things tend to even out. As long as your measurements are not like less than 5 feet, then go ahead and make it just centimeter, no decimal, no millimeters, and it's perfectly fine to do inches. You do not have to do centimeters. It's perfectly fine to use English or imperial measures, which is feet and yards and inches and miles and all that kind of stuff. However, once you've done it, convert it all to inches. Do not try to use feet and inches. What did she say? Don't try to use some feet, some inches. No, no, no. Make them all the same units and make them the smaller one, which is inches. So to the nearest inch is fine. And so if you have 7 foot 2 inches, well, 7 foot is 84 inches plus 2 is 86 inches. So record it as 86 inches. If you want to put 7 foot 2 and then put equals 86, hey, that's fine too. That shows your process, and that's a good thing. Okay? So you're going to record all the data here on this chart, and this is not new. You're just putting it all here together so you can look at it. That's all you're doing. Okay? So you put it all together here so you can look at it. Okay? And then remember each time, a reminder, you need to be at different distances from the thingamajig when you're doing it and when your partner's doing it. Then after you've done that and seen all of your data, you know, some of it may look screwy. You know what? That's life. That's okay. If you can look back over it and figure out you did something wrong, well, then correct it if it's a big thing, you know. But what I want you to do, and this is important, is in your summary and conclusions here, go ahead and write down what you did and analyze whether it should have been that way. Like if you got X height for the thingamajig when you did such and such, and you got Y distance from the thingamajig, and you know, if whatever you did, analyze it and tell me, is it reasonable? Now, the tools that we're using here, yeah, no, these tools will not get us to the moon and back. These do not have that level of accuracy. So even if you've done everything exactly right, you may not get the same answers because human error and the devices are not all that accurate. So the purpose of this is to tell me what should it have been the same number, what might have made it not the same number, should it not have been the same number, why would that happen or not. You're going to make me a flip grid, and you're going to turn that into, this is going to be a major grade. Make sure you read everything and do it all the way you're asked to do it. And I think you're going to find when you do it that it's actually quite a bit of fun. At least I hope so. I'll look forward to seeing your results and your flip grids especially because that's fun.